Welcome to the video tutorial on interrupted time series. This is a three-part series that illustrates how to evaluate retained data using interrupted time series. In the first part of this video, we will briefly review the interrupted time series analysis, steps needed when using this method, and will prepare a retained data set for analysis. The second part focuses on single group interrupted time series and part 3 on multiple group interrupted time series. This presentation is in partnership with Data for Impact, also known as D4I. D4I works to generate strong evidence for program and policy decision-making, build individual and organizational capacity, and enhance the use of data for global health programs and policies. Our objective today is to create video tutorials on how to use specific methods and commands to analyze routine data for evaluation and research. Keeping in mind that this video is not intended for beginners, but for those who have some experience with data analysis and Stata, the statistical software we will be using. We will explore two analytical approaches used to evaluate routine data. The first is interrupted time series analysis, our main focus in this video, and the second, logistic regression. More information on the different types of methods used to analyze routine data, as well as the materials used in this presentation, can be found in the D4I website. Now let's talk about interrupted time series. Interrupted time series, which will also be referred to as ITS throughout the video, is a quasi-experimental method that has wide applications in epidemiology, medication research, public health legislation, as well as program evaluations. It has been used when a randomized controlled trial is not feasible or ethical. It is used when interventions targeting population health outcomes are introduced at the population level over a clearly defined period. It evaluates the longitudinal effects of interventions through regression modeling. ITS compares the level and mean trend in outcome indicators before and after a breakpoint. The breakpoint is referring to the intervention, the policy change, or the interruption. ITS uses data collected at multiple points before and after an intervention to determine the impact of the intervention. It can identify the level change, which is the immediate effect, the slope change, which is the sustained effect, or both. It can be used to compare pre- and post-event policy or interruption. It can be used to compare trends before and after a policy change or event or interruption. It can be used to evaluate trends as well as variance. So there are a few benefits for using ITS. It is one of the strongest quasi-experimental designs when a randomized controlled trial is not possible. It detects changes that are delayed or intermittent. You can use retrospective data in the analysis. It controls for secular trends in the data, unlike a 2-point or 2-period before and after t-test. And it controls for long-term trends in the data. Like many methods, there are limitations. ITS requires multiple data entries. Some researchers suggested that a minimum of 8 periods or observations are needed before and after the event or interruption or program. Thus, a total of 16 data points are needed to consider using this approach. Secondly, when there are independent and separate components of the intervention, it can be difficult to differentiate the effects of the various components, especially if they're implemented close together in time. And the last limitation is that ITS requires population-level data, and thus inferences cannot be made at the individual level. There are two ways that ITS can be analyzed. The first is without a control group, and this is known as a single group interrupted time series. Using this approach, there is one cohort being analyzed. The second part of the ITS video tutorial will focus on this design. And so with both types of interrupted time series, we require 2 segments. One segment of observations before the intervention, and the next segment after the intervention. And as the diagram illustrates, we'll need 8 time periods before and after our intervention. And how do we know we have an intervention? Our X represents, and our arrow pointing to it tells us that we have a program, intervention, or policy that occurred. The second example or study design used for ITS is the multiple group ITS. So in this case, it includes a control group. So we have more than one cohort that is being analyzed, and you will notice that we have two separate lines here. So in the first line, we have our exposed group because they are exposed to the intervention, and our unexposed group are not exposed to the intervention, or our control group is not exposed to the intervention. And the third part of this video tutorial series will focus on the multiple group ITS. There are several examples of studies that have used ITS, and a list can be found on the background information sheet that is available as part of this video tutorial series on the Data for Impact website. However, for now, we will discuss just two. So in the first study, we present titled Use of Routine Health Information System Data to Evaluate Impacts of Malaria Control Interventions in Zanzibar, Tanzania from 2000 and 2015. Ashton and his colleagues used routine health management information system data from Zanzibar's public health facilities, obviously using interrupted time series, to estimate the impact of malaria control interventions on confirmed malaria incidents and case management. So as we've seen in the title, they used data from 2000 to 2015. And so this is an example of our single group interrupted time series because they did not have a control group. So in this case, our program or event or interruption is the malaria control interventions that were conducted, and our outcome is the malaria incidents and case management. The second example by Hung and colleagues was conducted, or the second study was conducted in the Democratic Republic of Congo. And they examined the rates of the use of 9 health services in primary health facilities. They use interrupted time series analysis to estimate changes in the rates of services use during a free care policy that was implemented in June to September 2018 and afterwards. The analysis included control groups. So we know this is an example of the multiple group interrupted time series. And they use monthly data from the National Health Management Information System that was collected from January 2017 to January 2019. For more examples of studies using interrupted time series, I encourage you all to refer to the background information sheet available on the Data for Impact website. So in order to run or to analyze or use the interrupted time series method, there are a couple of steps that you want to follow. So the first is to determine the time period or time periods. So this is a period during which the intervention or policy occurred, and there can be more than one. As a reminder, you need to have at least 8 time points before and after the event, intervention, and policy. So you have 8 before and 8 after at least. Next, you want to identify the analytic cohort. So it's your cohort should really be the people who are affected or the ones who are affected by the policy during the entire time period. And this shouldn't be a problem if you're looking at an entire region. And at this period, you also want to determine if there's a control group or unexposed group that you can use to strengthen your study design. The control group doesn't have to match, but it's better if their pre-trends are the same as that of the exposed group. And it's important to ensure that if the control group is identified, or if our control group is identified, they have the same number of data points as the intervention group. Third, we want to identify the outcomes of interest if it hasn't been done so already. Fourth, you want to set up your data and visually inspect this data. And so in your data, you should have the outcome, the unexposed cohort, if applicable, the time period of the interruption. Depending on the state of command that is being used, you may also need to have an indicator for the post-intervention period and an incremental time period for your post-intervention time. And as you set up your data, you should run graphs to visually inspect the data. And during the assessment, you want to look for wild points, linear trends, co-interventions, and any other data quality issues. Next, you want to perform your preliminary preliminary analysis, you want to check for autocorrelation and address it if applicable or if present. Then you want to run your final model that would address autocorrelation and plot the results. And finally, you want to predict the relative and absolute effects. And so we'll go through these steps using a fictional example from a country called Exile. In our example, our data comes from Exile, a fictional country. In November 2017, Exile introduced a policy that eliminated fees at health facilities associated with maternity care services, with the aim of increasing the utilization of health services and ultimately improving maternal health outcomes. The policy was piloted in 2 constituencies, Gold Coast 9 and Gold Coast 15, and the North Troy was used as a control group. For analysis, we received health facility data on the number of women who attended their 4th ANC visit from 2017 to 2020. The data was from the District Health Information Software, and the data can be aggregated at various levels. So on our right in the diagram, we see the different levels that you can aggregate the data. There are 5 different levels. We received our data at the health facility level, which is the lowest level. The next level up that you can aggregate your data to is the district level, followed by the constituency level, then the regional level, and lastly, the highest level, which is the national level. Using the data received, we wanted to answer the 2 questions. What was the impact of the policy on the utilization of ANC, specifically the 4th ANC visit of pregnant women in the Gold Coast number 9? And the second question, what was the impact of the policy on the utilization of ANC, specifically the 4th ANC visit of pregnant women in the intervention constituency in Gold Coast number 9 compared to the control constituency, North Troy? As we can see, the data we received was at the facility level, but the question requires constituency level data. Thus, we will need to aggregate our data to the constituency level before we can answer this question. So to avoid this extra step, it's advisable to download your data at the level at which you are interested in. In this case, it would have been ideal to download the data at the constituency level, so we won't have to aggregate the data. So now we're going to prepare our data set before we answer the questions. I encourage you all to follow all the parts of the tutorial because the 2 questions that are 2 research questions will be answered in part 2 and part 3 respectively. So this is what our downloaded data look like. As you may notice, our data is in the wide format, and we have monthly data on the number of women who attended their 4th ANC visit at each facility. We renamed all the variable names to ensure that they were consistent. This is important, especially if you are merging data as well as reshaping data files, and we will go through the reshaping data. So we had to make sure that all the names, the variable names in our data set were exactly the same. To prepare our data, we will first assess for missing data and duplicates. We will aggregate our data, change it from health facility level to the constituency level because we received our data at the health facility level and our research question is at the constituency level. We will reshape the data from wide to long and we will format the dates. We'll first go through majority of these steps in data. For this tutorial, we're assuming that health facilities without data points had no ANC visit. Thus, we're focusing on the last 3 steps. In reality, if there is missing data, you want to assess for the type of missingness and try to resolve it. We will not go into detail today about the missingness of data, but in the resources provided, specifically the background information sheet, as well as the end of this video, there is a webinar that provides an in-depth overview on how to assess and deal with missing data, and I encourage you all to watch this. Going straight to our data aggregation. Our data was downloaded at the health facility level, so we want to aggregate it to our level of interest, which is the constituency level. Before doing this, we want to check to make sure that there are no duplicate health facilities using the duplicate tag command. For this command, you want to include the variable list as well as create a new variable where the results can be stored. And to see your results, you want to tabulate your new variable that is storing your duplicate information. We run the duplicates tag command on the facility, which gives us the variable for the list of facilities in our data set. In this case, we included only facility in the variable list, and this indicates that we have several duplicates. However, once we reviewed the data, we realized that different districts, constituencies, and regions had health facilities with the same name. So we needed to include these variables as well in our duplicates command. So we rerun this, including regional, constituency, district, as well as facility in our duplicates tag command. And the tabulation of our new variable where we stored our duplicates, dup_hf, indicates that there are no duplicates of health facilities as we previously thought. So now we're ready to aggregate our data to the constituency level. Using the egen command, we calculated the total number of fourth ANC visits recorded in each constituency for each month. So you'll need to identify the outcome variable for each month and the level of interest in the command to use it. This is an example of what we run for January 2017. We asked data to generate a new variable called con ANC for Jan 2017_1 by adding up the counts of ANC visits in January 2017 for each constituency. And as you can imagine, we have data from January 2017 all the way through August 2020. And instead of repeating this for each month, we use the loop command in stata. And this is an example of the loop command we use. And so it basically replicates the commands in the loop. So for more information, you would want to search help for each, and stata will give you more information on how to use this particular command. So it's best to transform the counts of ANCs to rates per 1,000 population to account for changes in population sizes from one constituency to another. So using the gen command, again, we divided the counts of ANC for each month by the number of women of reproductive age in the constituency of interest for each month. So our stata command is here where for each ID, region, and constituency, we generated our con ANC4, so our rates at the constituency level for each month. And again, we have several months, so we used the loop command in order to do this. After this was done, this is what our aggregated data set looked like. From the screenshot, you can see the variables for region, constituency, number of facilities in each constituency, and the rates of antenatal care in January, February, and March at each constituency level. So next, you want to reshape your data. Currently, our data is in the wide format, which is the first screenshot we can see at the top. But at this point, if you haven't already done so, it's important to make sure that your variable names are all the same before the reshape is completed. So we'll go through all of this and how to reshape our data in a stata demonstration in detail in a couple of minutes. But when we look at this, we can tell we go from wide, we run our command, and data reformats the way our data is appearing. And now we have the long format. And we'll go through this in detail in a stata demonstration. After the reshape, your dates will be stored as a string variable, and we'll need to format it accordingly so it can be recognized by stata. Depending on your research question, data available, you can format the dates for it to be daily, weekly, monthly, quarterly, and yearly. For our data, we want to format our dates as a monthly format, mainly because we have monthly data. And so we'll go through how to format our data in detail in the data demonstration following. We'll focus on formatting the date to be monthly because that's the data we have in the data set. And so for more information on other date styles on this video, you can search date time in stata. Search help date time in stata. Now let's move on to our stata demonstration. In this video, I will illustrate how we reshaped our data and how we formatted the dates in our data set in order for it to be recognized by stata. These steps were completed while we're preparing the routine data for analysis. The data set has already been opened in Stata, so we're going to go ahead and start the process. Before reshaping, let's take some time to explore our data set using the describe command, and I'm going to move to our do file to run this. The describe command, as we can see, describes the data in memory. Currently, we have 3 observations in our data set and 49 variables. Our variables are stored as either long or float. We have various variables, 49 of them. And so the first one is region, which represents the region, constituency representing the constituency. ID is the unique identifier for each constituency. We have a variable for the number of health facilities in each constituency. We have the variable for the rates of 4th ANC visits for each month, starting in January 2017. All the way through August 2020. And lastly, we have a variable for the number of districts in each constituency. Next, let's examine if we have any missing data in our data set using the command mdesc. So going back to our do file, we will run this. Focusing on the missing column, when we scroll through and we look, we notice that we only have values 0 as our value. And this tells us that we don't have any missing data. The next thing we would want to check for is for duplicates. And if it's present, you want to resolve this. So going back to our do file, we're going to use the duplicates tag command. And this identifies all the duplicates in the variable of interest, which in this case is our ID variable, the unique identifier for the constituencies in the data set. We're going to ask Stata to generate a new variable, dupe_con, and store our results. So this variable dupe_con is chosen based on the user. So you can choose any name that you would like. And so we're going to run this. And to view our results, we want to tabulate dupe_con. And so looking at the tabulation, we realize that we don't have any duplicates in our data set, which is great news. So we can move on to the reshape step. We're not going to use this variable again, so we want to drop it. So now that we're done exploring our data, let's move on to the reshape step. Currently, some of the variables in our data set, specifically our con ANC4, which is our variable for the constituency rates for the 4th ANC visits, are in the wide format, and we want to make them long. So to do this, we're going to use the reshape long command. However, before we can do this, we need to discuss a few things. We first need to identify the variables needed. The first one we're going to need is as the base name, which can be found in the names of the variables we want to make long or reshape. So let's go ahead and list the constituency rates of 4th ANC visits for January, February, and March 2017. So I want us to focus on the actual command, not the results it produces. So looking at the first variable, con ANC4 Jan 2017. We can identify the base name and the date for each constituency rate. So in this case, our base name is con ANC4, and the date, which is basically when the constituency rate was recorded, is January 2017. And we can do this for each of the variables we've listed. So looking at the second one, our base name is con ANC4, and our date or when it was recorded, it's February 2017, and the same thing we can do for the March 2017. The next thing you need for your reshape command is to identify the sub-observation identifier. So this particular variable is not actually in the data set and will be created during the reshape. So let's go back to the do file and look closely at our reshape command. So as we said previously, we're moving from a wide to long format. So we're going to use the reshape long command. We're going to indicate the base name, which you've identified as con ANC4. Next, we need our ID variable, which is I, and in our case is ID, and it's our unique identifier for each constituency. Next, we want to identify the sub-observation identifier, or J, and we are calling this SM date. And lastly, we're including string because we're telling Stata that as we want SM date to be a string variable. So now let's run this and view our results. So our reshape was successful. In the wide format, we had 3 observations and 49 variables. Now in the long format, we have 132 observations and 7 variables. We created a sub-observation identifier, our J variable, which we called SM date. And this indicates when each observation was recorded. And con ANC4, our base name, is now a variable on its own. To see if we want to explore the variables or the data in our data set, we can use the list command. However, this will run every observation in the data set. If we want to restrict this and see the first 20 observations, we include in 1 out of 20 in the command. So as we can see, SM date is a variable on its own, and it indicates the month and year the observation for con ANC4 were recorded. And also on the right here, we see that con ANC4 close on the last but one column, cons ANC4 has been listed, and it's now its own variable. I want to take a second look on the variable list on the right. So we'll notice that SM date and con ANC4 are not labeled. And as good practice, I suggest providing variable names so you know exactly what they mean. And so to do this, you use a label variable command in Stata, and you'll put the label name in quotes. And so looking back again to our variable list, we'll notice that now SM date has a variable name and con ANC4 also has a variable name. So now that we're done reshaping our data, we can move on to formatting our dates. Currently, our date variable created in the reshape is a string variable. So SM date is a string variable. And we can tell this by using the describe command and including the variable name SM date. So as we can see, our storage type is a string variable, and this isn't recognizable by Stata as a date, and we'll need to change the format for it to be recognized. So going back to our do file, we will use the generate command to convert our date to a form that is recognizable by Stata. So first, using generate, which for short gen. Next, we'll indicate the time variable that we want to create. We've chosen the name mdate, and you can pick any name that you like. Then monthly, and our data is monthly, and we're telling Stata that we want a monthly date, or it is a monthly date. In the parentheses, we have the name of our string variable, SM date, and the format the date is displayed in SM date. So in this case, it's month, then year. So we indicate MY. Once we run this command in Stata converts our string variable to a recognizable date variable. And we're going to also go ahead as good practice to label our variable mdate. So let's go ahead and run this. So something has happened. To see our results, we want to tabulate mdate. So as we can see, when we tabulated the mdate, the data are recognizable and are to us and are not in a readable format. It's in a format recognized by Stata, which is called the Stata internal form. We'll need to convert the Stata internal form to a human readable form. And to do this, we want to use the command format mdate %tm. So by doing this, we're telling Stata to now show our data in a monthly format, and Stata will display the date in a form that we can interpret. So let's tabulate our mdate again to see if this worked. So now looking at this, we can recognize this. So let's pick the first one. So our first observation, or this observation was recorded. These 3 observations were recorded in the first month of 2017, so January 2017. And if you look at all the other dates, we will understand what exactly the dates they are referring to. It's no longer in a form that is unrecognizable to the human eye. To summarize, interrupted time series is a strong quasi-experimental design that uses data collected at multiple points before and after an intervention to determine the impact of the intervention. It can identify the immediate effect, sustained effect, or both. And to prepare our routine data for interrupted time series analysis, we need to assess for missing data if necessary. If necessary, aggregate our data, reshape the data, and properly format our dates. This is the end of part 1 of the ITS video tutorial. We have several resources available, a background information sheet on interrupted time series, the presentation used today, as well as the stata do file and sample data sets for part 2 and 3 of the interrupted time series video tutorial. And in part 2, we'll review the single group interrupted time series.